Okay, children. So, children, yesterday I discussed 8.2, first, second, and third sum, children. 8.2. So, today I will discuss 8.2, fourth to seventh sums. Okay, children. So, coming to fourth sum, children. Fourth sum is given like this figure. All of you, please check the figure in the textbook, 9th class textbook, quadrilaterals, page number 105, 150, children. So, children, this is given A, this is given B, this is given C, this is given D, and there is a diagonal joining B and D. There is a parallel line which is named as E and F. Okay, so let's write here given, children. Given is compulsory, you should write. ABCD is a trapezium. He said ABCD is a trapezium, children. Means CD is parallel to AB. One sides are parallel. In trapezium, one sides are parallel. We know that. Okay, children. BD is diagonal. E is the midpoint. E is the midpoint of AD. Children, E is midpoint of AD. D is midpoint of AD. Means DE is equal to PE. Indirectly, he is saying DE is equal to this and this are equal. Okay. Yes, and he said, children, EF is parallel to AB. EF is parallel to AB, but AB is already parallel to CD. So these three are parallel over, children. Okay. Now required to prove. What is required to prove? We have to prove that F is also midpoint. This way. E is midpoint, we have to prove F also midpoint. Children. Okay, children. Now I'll put here G. Okay, children. So, children, yesterday I told, try to understand, children, all of you. If E is midpoint, G is midpoint, this is parallel to this I said. But already these when these are parallel, he said, children. So by converse of midpoint theorem, reverse of midpoint theorem, reverse converse means reverse of midpoint theorem. Try to understand, children. See, let it is meeting a point or at a point in G. I'm writing here G. Okay, children. E is midpoint. Why given? E is midpoint. Why given? And EF is parallel to AB means EF is also parallel. EG is also parallel to AB. No, children. If full line is parallel, won't a half line be parallel? So EG is parallel. E is midpoint by converse of midpoint theorem. We should say converse of midpoint theorem. Converse of midpoint theorem. G is also midpoint. Okay, children. Direct theorem is if these both are midpoint, this is parallel. Converse is if this is midpoint and these both are parallel, this is also midpoint. Again, I'm saying converse is if this is midpoint and these both are parallel, this is also midpoint. Again, I'm saying if this is midpoint and these both are parallel, this is also midpoint. Oh, now go to triangle BDC. Go to triangle BDC. G is midpoint. Why B proof? GF is parallel to CD. Why? Because AB is parallel to CD. This whole line is parallel to AB. AB is parallel to CD. So GF is parallel to CD. So children, G is midpoint. These both are parallel. G is midpoint and these both are parallel. By converse of midpoint theorem, I can say F is also midpoint over children. That's it. Converse of midpoint theorem. What is converse of midpoint theorem? Means if this is midpoint and these both are parallel, this is also midpoint over. If this point, these both are parallel, this is also midpoint. If this is midpoint, these both are parallel, this is also midpoint. If this is midpoint and these both are parallel, this is also midpoint. By converse of midpoint theorem. That's it. Hope I could convince you. This is fourth subject. Let's go to fifth subject. In fact, this is very easy. Converse of midpoint. Okay, children, reverse converse. Fifth. Children, they have given like this a parallelogram. I think ABCD is a parallelogram. Children, how they gave ABCD is a parallelogram. He said this is A, this is B, this is C, this is D. He said, and A F. They said this is C E. They said A C E. They said, and this is B. Given. Please see, children. Given. All of you see, children. E and F are midpoints, children. E and F are midpoints. E and F are midpoints. They have given, children. E and F are midpoints. They only give, children. Children, E and F are midpoints of midpoint A, B, and C, D. Okay, E and F. Show that AF and EC bisect each other. Children, E and F are midpoints they gave. He's asking required proof is what? Required proof is what? children, we have to prove that this is equal to this is equal to this. Don't unmute your audio, children. We have to prove that BQ is equal to QP is equal to DP. We have to prove, children. And he also said that ABCD is a parallelogram. ABCD is a parallelogram. He said. That's it, children. Okay, now we have to prove, children. Very, very easy, children. All the converses only, children. All the converses, children. First I'm showing, see, ABCD is parallelogram. Every point is important. If you don't understand, you will get confusion. Listen. ABCD is a parallelogram. AB is equal to CD. AB is equal to CD and AB is parallel to CD. AB by 2 will also be equal to CD by 2. And if AB is parallel to CD, then AE also parallel to CF. AE is also parallel. AB by 2, I can write AE. And CD by 2, I can write CF. Why? Because E and F are midpoints. This point, if you don't understand, you will be confused. This point compulsory should understand. AB by 2 is A. CD by 2 is CF. No, sir, I will write DF. It's right, children. No problem. But CF I'm writing because if opposite sides are equal and parallel, if opposite sides are equal and parallel, opposite sides are equal and parallel, then I can say AECF also parallelogram. AECF also parallelogram. Okay, children. So ABC is a parallelogram. So AECF also parallelogram. As AECF is parallelogram, AECF is a parallelogram. I can say EC is parallel to AF. EC is parallel to AF. Okay, children. Now, last step, children. BAP bar in triangle BAP. All of you see, children. In triangle BAP, E is midpoint. Can anyone say why?
Sir, given.
And EQ is parallel to AP. Can anyone say why?
Sir, we have proved it.
EQ is because EC is parallel to AF. Because EC is parallel to AF. This whole line is parallel. This small line is also parallel. Can anyone say what I should write by?
Midpoint theorem.
By midpoint theorem.
This is midpoint. This is parallel. This
Converse.
is converse of
Converse.
midpoint. By converse of midpoint theorem, Q also midpoint. If Q also midpoint, BQ is equal to PQ. Mute your audio, children. Someone audio. It's disturbing me. I think Nandika. BAP is over, children. Please mute your audio. Mute your audios, I said. Next one. DQC. In DQC, children, F is midpoint because it is given. F is midpoint because it is given. FP is parallel to QC. Why? Because EC is parallel to AF. Because EC is parallel to AF. These full lines are parallel. These small lines are parallel. So same, children. By converse of midpoint theorem, if F is midpoint, P also midpoint. Children, those who didn't understand, try to understand. F is midpoint, these both are parallel, so P is midpoint. Again, I'm saying F is midpoint, these both are parallel, so P is midpoint. Again, I'm saying F is midpoint, these both are parallel, so P is midpoint only in this time. So P is midpoint means I can say DP is equal to PQ. Now BQ is equal to PQ, DP is equal to PQ. From this both, what can I say? I can say DP is equal to PQ
Is equal to BQ.
Means what? It is trisected. Line BD is trisected. BD is trisected. Trisected means divided into 3 equal parts. Trisected means divided into 3 equal parts. Those who did not understand anything from the beginning, just I'm saying again, children, because this is a parallelogram, this whole line is parallel. If this whole line is parallel, the small lines are also parallel. And AB by 2 is AE, CD by 2 is CF. These both are lines are equal and parallel, so this is a parallelogram. If this is a parallelogram, CE is parallel to AF. CE is parallel to AF. CE is parallel to AF. I used that here and here, children. In this triangle BAP, E is midpoint, this is parallel. So Q is midpoint. E is parallel, these both are, sorry, E is midpoint, these both are parallel, so Q is midpoint. E is midpoint, these both are parallel, so Q is midpoint. And in this triangle, P is midpoint, these both are parallel, so F is midpoint. So because this is midpoint, these both are equal. This is midpoint, these both are equal. All sides are equal, so VD is trisected. VD is trisected. Okay, children, I hope you understood. 6 is you must enjoy the sums, children. If you enjoy the sums, really, they are very, very beautiful sums. Okay, unlike algebra, you have to prove everything. Show that line segments joining the midpoints of opposite sides of quadrilateral bisect each other. This is just a quadrilateral. This is just a quadrilateral. A, B, C, D. And he's saying that midpoints of opposite sides. He's saying this is midpoints. P, Q, R, S. This line bisect each other. So given children, ABCD is quadrilateral. What quadrilateral? He didn't give children. And but he said P, Q, R, S are midpoints. Required proof is what, children? We have to prove that PR bisects SQ. PR bisects SQ. Bisects means what, children? This and this are equal. This and this are equal. We have to prove. We have to prove that PR bisects SQ or SQ bisects PR. Anything is same. That we have to prove. Bisects means this and this are equal, this and this are equal. We have to prove, children. Chalo, let's prove, children. This is like this. K, A, B, C, D. P, Q, R, S. Children, I'm joining them. Okay, children, after joining them, I will join AC. No, sir, I will join BD means you are wish, children. You can join anything. Anything you can join. Now, can you see anyone A, B, C? There is one triangle. A, B, C. In A, B, C, P and Q are
Midpoints.
by
Midpoint theorem.
Midpoint theorem.
PQ is parallel to
AC.
AC.
and PQ is
Half of AC.
Half of AC.
half of AC. In the same way, children, BAC. In the same way, BAC. S and R are
Midpoints.
by
Midpoint theorem.
SR is parallel to
AC. SR is equal to
Half of
1 by
AC.
half of AC.
SR is half of AC. Okay, children. SR is parallel to AC. SR is half of AC. No, children. PQ is parallel to AC. In same way, SR is also parallel to AC. Means PQ is
parallel to SR.
Yes, sir. Okay. Nandika, please cool down. Nandika, please. Nandika. I'm very happy that you are saying, but what is the thing is, I don't know, sir. Others are not saying I'm feeling. Nandika, but I'm very, very happy. PQ is half of AC, okay, and SR is half of AC. So PQ is equal to SR. Okay, children. Now what we can say? Opposite sides are
Equal and
Parallel.
opposite sides are equal and parallel. If opposite
It is
sides are
a
equal,
parallelogram.
who is parallelogram?
PQRS.
ABC.
PQR.
PQRS is a parallelogram. PQRS is a parallelogram. Children, PQRS is a parallelogram. Please see here.
Parallelogram.
See, children, all of you understand, try to understand. This is A, this is B, this is G, this is B. Now, please see, children, here, try to understand. This is P, this is Q, this is R, this is S. Now, if PQRS is parallelogram, what is PR and SQ called as? PR and SQ are called
Bisectors.
diagonals.
Bisector.
Diagonals. PR and SQ are called diagonals.
Bisectors.
PR and SQ are called diagonals. For diagonals. PR and SQ are called diagonals. Of what? Diagonals of parallelogram. They are called what? Diagonals of?
Parallelogram.
Diagonals of parallelogram. But what we know in parallelogram?
Diagonals bisect each other.
Diagonals bisect each other.
In parallelograms, diagonals bisect
Each other.
diagonals bisect each other. So who is bisecting? Who are bisecting?
PR is
PR is
bisect
bisect
SQ.
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 PR and SQ bisect each other. PR and SQ bisect each other.
Each other.
That all, he asked to prove. He asked to prove that all, children. So, children, what I did, first I proved PQRS is a parallelogram. How I prove, you know. Once it is a parallelogram, then I can say PR and SQ are by diagonals of parallelogram. We know diagonals of parallelogram bisect each other means PR and SQ are bisecting. We know diagonals of parallelogram bisect each other. We know diagonals of parallelogram bisect each other. We know diagonals of parallelogram bisect each other. That's why PR bisect SQ. Simple. I hope you enjoyed the song. Nandita is rocking. Okay, children. Next. Seventh. ABC is a triangle right angle at each other. ABC is a triangle right angle at C. ABC is a triangle right angle at C. Okay, a line through midpoint M of hypotenuse AB. M is midpoint. Here a line is drawn. A line through M midpoint of AB is parallel to BC. He said these both are parallel. Parallel to BC by intersects AC at D. Intersects AC at D. Okay, children, what is a very, very beautiful structure? My favorite structure. Angle C is 90 degrees, he said. M is midpoint, he said. M is midpoint means AM is equal to BM. AM is equal to BM. AM is equal to BM. And he also said that MD is parallel to BC. Now, what are we required to prove? Required to prove is number one. First one, we should put that D is also midpoint. Second one, we have to prove that MD is perpendicular to AC, means D is 90 degrees, we should prove. Angle D is 90 degrees, if you prove it is a perpendicular. And C is CM is equal to AM is equal to half of AB. Oh God. Okay, children. So, children, M is midpoint. Why?
Sir, given.
Given, sir.
MD is parallel to BC. Why?
Given, sir.
Given, sir.
By.
By midpoint
Midpoint
theorem.
theorem.
Midpoint theorem.
Converse of midpoint theorem. D also midpoint. No one told. No one told. Very bad. D, M is midpoint. These both are parallel. So D is midpoint. M is midpoint. These both are parallel. So D is midpoint. By converse of midpoint theorem. Oh, first one is good. Now, children, BM is parallel to BC. Why? Anyone?
Sir, given.
Given. Can anyone say? Angle B and C are called?
Yes, sir.
Sir,
Interior angle.
co-interior angles.
Angle D and C are called co-interior angles. Co-interior angles are?
Supplementary.
Co-interior angles are supplementary. Co-interior. So angle C plus angle D will be equal to?
180 degrees.
But angle C is 90 degrees already given. Angle D is
Angle D is also 90 degrees.
Angle D also 90. So MD is perpendicular to AC. Oh, second also proof. Last proof. Last proof. Join CM. Join CM. Children, when you join CM, it looks like this. AC. When you join CM, it looks like this. Yes, children, there are two triangles. One is MAD mad. MAD mad. Another one is MC.
MDC.
MAD MCD. Okay, children. So in this both, MD is equal to MD. Why, children?
Common.
A common side.
Common side.
Angle D is equal to angle D. Anyone?
Sir,
90 degrees.
We proved. Where we proved. Okay. AD is equal to CD. Why, children?
D is midpoint.
D is midpoint.
D is midpoint by SAS.
SAS.
Side angle set by SAS. MAD is congruent
Congruent to MCD.
by CPCT. By CPCT. AM is
Yep,
equal to
equal to
Equal to CM.
AM is equal to CM.
TM.
But AM is already equal to BM. AM is already equal to
BM.
Given.
given that is. So now what we write, children? Last step, children. AB. What we can write AB, children? AB we can write as AM plus BM.
AM
2 AMs.
plus BM.
AM plus
2
AM is
AM.
2AM. Why? Because AM and BM are equal.
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 So AM what we can write half of AB.
Half of BAB.
So if you find AM is equal to half of AB, but AM and CM are equal. AM and CM are equal. So CM also equal to half of AB.
Half of AB.
AM and CM are equal. AM and CM are equal. Why they are equal? Because they both are congruent. Because they both are congruent, AM and CM are equal. This is seventh sum, very important sum and most beautiful sum. Okay, children. So some more examples are there, children. Examples I will say in the separate video. Thank you, children. Let's go to science.